Yeah, so my name is Alejandro. I'm with Forterra. I'm a structural engineer there.
All right, I'm Brett McChesney. I'm the engineering manager at MCon over in Carp. We're going to be talking, about pipe bedding and installation. First, we're going to start off with just an explanation of what our strength classes mean. So you would have seen at the previous station that steel cage, the spiral cage. Basically, our concrete, when you guys are inspecting on site, the important thing to check with our pipe is that all the strength classes all look the same. There's no thicker walls or different lengths or whatever. It's always, for a given size of pipe, the wall thickness is always the same, length is always the same, the concrete's the same. It's just how much steel is in it. Stronger pipe just have more steel in them. So we can change the diameter of that wire in the spiral. We can change how many cages there are, 1, 2, or 3. We can change the spacing of the loops as it goes up. So that's the only difference. So it's important to make sure the contractor is grabbing the right strength class out of the pile on site. So our classes are 50, 65, 100, and 140D. And what that means is, for our example of, we've talked about a 450 millimeter or 18-inch pipe. For a 140D, it has to be able to handle 140 newtons of force per meter of length per millimeter of diameter. So in this example, if you take 140 newtons times our 2.44 meter or 8-foot length times 450 millimeters of diameter, works out to 153,000 or 153 kilonewtons of force. Divide that by force of gravity, gives you equivalent weight or mass. Works out to 15,670 kilograms that this 18-inch pipe can handle over a meter of length, which works out to 6 Suburbans you can pile on that 1 meter length. And as my wife tells you, I own one of these and she hates driving it because it's like 2 meters wide. So in theory, you could put 12 of these on a 2 meter wide. Like if you got pipe under it the full width of the truck, you could put 12 of them on top. And that's before it even cracks. It gets to what we call our 0.03 millimeter crack, or it's 1/100th of an inch technically is what it is. So we test them. We have hydraulic presses in our plants to squish the pipe. And so we'd have to get up to 153,000 kilonewtons or 153 kilonewtons before this pipe gets to that crack that's 0.3 millimeters wide. And then there's what we call the ultimate load, which is how much it has to handle before it can't take any more. The concrete's all cracked and the steel just stretches and squishes. So that's 50% more than the 140, than the 0.3 load. So it's important, just what we wanted to tell you guys as inspectors is make sure that run that calls for a specific class, they're putting the right one in, because you can't tell, without reading the label on the inside, you can't tell from looking at it on the outside, oh, that's, plastic pipe could be different colors for different classes. You got your thicker blue for the water main and thinner green for sanitary or something. But with ours, you have to read the label on it to make sure you got the right one.
That's right. And the other big thing is when you were mentioning about the hydraulic test, that's a point load test. Well, 3-edge bearing test, 3-point load, but basically it's almost 1 on top, 2 on the bottom, but very close together. So in the field, that's not the kind of situation you're going to find yourself in. So the pipe's actually a lot stronger than what appears in our tests. Speaking of strength, there's a big difference between how you install the pipe and how it behaves and what pipe strength you need. I'm going to talk about the differences between a confined trench installation as opposed to a positive projection or embankment installation. On a confined trench, you have undisturbed soil on each side of the trench. When you install the pipe and you add your backfill, a lot of the backfill is going to be carried by frictional forces on the walls of the trenches itself. That's because the outside or the undisturbed soil is stiffer than the new stuff that you're adding in. So the pipe is actually carrying less than what's directly above it. The opposite actually happens on a positive projection installation, where if you were to divide this into 3 columns, just like we did before, you have the exterior prism or columns are all new soil, but it's going to be less stiff than the middle. The middle column is actually the stiffer one in this case, because you have a concrete pipe that's rigid. As the soil settles, it's going to settle more on each side of the pipe, which means that the middle prism is going to carry some of that load of the adjacent soil. So you end up having a bit of carrying more than what's directly above the pipe. So for the similar pipe, similar depth of cover, you might specify a lower strength class on something like this, on a trench, than on a positive projection. Or if you have the exact same pipe, let's say a 65D pipe, you might be able to go deeper with the trench. So now it's tough to get to a trench installation. It's very stringent to get those benefits, and I'm going to talk a little bit about that on these two specifications from the OPSD. This one specifically talks about the difference between a rigid pipe and a flexible pipe when it comes to installing it. In Ontario, there's a class, we are allowed to use a Class B bedding or a Class C bedding when it comes to a rigid pipe or concrete pipe in our scenario. And the main difference is how much hunch support, how much bedding material we put underneath the pipe. On a Class B bedding, we have to go up to the spring line of the pipe, or halfway, 50% of the OD of the pipe. With a Class C bedding, you're only at least a minimum of 15%, 1.5. So it's less hunch support, which means it's a bit of a trade-off, again, when it comes to cost and strength. In a scenario with a Class B bedding, you're spending more on the bedding itself, but that additional support means that you might specify maybe a lower class, cheaper pipe, or less expensive pipe. With a Class C bedding, you sacrifice some of that hunch support, meaning you need a stronger pipe, but you're saving on the bedding. Now, I don't know the numbers exactly, but I haven't seen many jobs or projects specifying Class C bedding. Most engineers, consultants are specifying Class B. The other important fact I want to point you out here is from the same spec is the maximum trench width allowed to get the benefits of a proper confined trench. And it depends on the size of the pipe. So a 900 millimeter pipe or smaller, you only allow a maximum of a foot or 300 mils on each side of the pipe to the trench box or to the trench. For larger pipes over 900, you allow up to half a meter. Now, it's not a lot, especially if you want to get in here with and pack the bedding here. It's not a lot of space in between there, so it's easier to violate these rules. Hard to comply by them. So in the field, sometimes it's tough for contractors because they have set. A lot of them use trench boxes because the soil not being to a point that it can sustain itself to the use of trench boxes, and these trench boxes are specific width. Now, they don't have one for each pipe diameter that we sell, so you might get a trench width or a trench that is wider than what's specified here. So you might be somewhere in between here. You might not get the full benefit of the confined trench. When it comes to flexible pipe like PVC, CSP, HDPE, so on, so many of them now, it's a little bit different how you install them. That you need full bedding material on the pipe, all the way up to a foot above the pipe. And again, it has to be compacted similarly to a concrete, but in lifts, all the way to the top. And the reason why we have that extra material is that simply the flexible pipe in its own, it's not very strong as per se as a concrete pipe. In here you have a structure as well as a conduit. In itself, here you rely on the structure around it, which in this case is the soil and how well you compact it. The pipe itself is about 5%, carries 5% of the strength. 95% is on the bedding and how you compact it. So as you guys are inspecting on the field, that's key there, making sure that they're properly compacting specific lifts of a foot, I think is the maximum. So something to keep in mind. Any questions so far? This? Okay. One specific addition to the 4100 done last year to the specification of the City of Ottawa was the addition of this specification for concrete pipe installed on a rock trench. So especially 1200 diameter or larger, so large concrete pipe. And the reason why we did this, the precasters alongside the CCPA work with the city, is that there were issues with some pipes being installed deep in rock trench and showing cracks, even though they were the proper class. And what's happening is, as you got rock on each side, the pipe was being point loaded by a bedrock here and the load above. So what we have recommended is the use of a loosely placed bedding in the middle third of the pipe. That allows, it simulates a bit of a cushion for the pipe to sink in ever so slightly and allow the haunches to engage, so you got full support rather than pin loading that pipe. So you want to compact each side, but leave the middle somewhat uncompacted. The other thing that seems to have worked, especially when you have expansive rocks or soils like clay shells or even limestone, when exposed to humidity, they tend to expand. You want to add this styrofoam. 2 inches styrofoam really helps us. As this rock wants to expand, the styrofoam will be the sacrificial piece, almost like it will expand into it rather than crushing the pipe itself. We have a little demo
Yep.
here.
So as of the, just to illustrate the different beddings that Alejandro was talking about, with a concrete pipe, you've got your bedding up to spring line, and it's a structure in itself, so you can put your load on there with your proper compacted bedding, and it's going to function properly. With your proper bedding all around a flexible pipe, whether it be CSP, plastic of any kind, as long as you've got your proper bedding, you can put your load on there and you're fine. Now, without the proper bedding, like say for the same scenario as a concrete pipe, it's the volunteer, come on down. Okay. What would happen is, obviously, as expected, it can't take much load without the proper bedding around it, right? So you'll end up with, if you bedded it the same as a concrete pipe, you'd end up with half a pipe. So that's something just to keep an eye on in the field when they're doing plastic pipe. It's crucial that they have the proper bedding all the way around it. In 2019, the province came out with these excess soil regulations. So not almost everything you dig up on site has to be tested to determine if it's a waste product that needs to be disposed of or not. So like Alejandro was saying, with concrete pipe, you only have to support it up to the spring line or even 15% of the diameter for Class C. This is a Class B we show here. With the plastic, since you have to encompass the whole pipe with your granular bedding material, you have to excavate all this and replace it with the granular bedding, so you need to dispose of that soil somewhere. Whereas with the concrete pipe, again with the City of Ottawa Spec 4100 there, F4100, you can use some of the native material as your fill again. It has to meet some requirements. There are some examples on the table here, but in the spec it says contractor must use granular A material for the bedding and haunching area up to the spring line of the pipe, and then granular B, A, or select subgrade material with 100% passing the 37.5 millimeter sieve. So that's 1.5 inches diameter, or 1.5 inches grid in the sieve. So basically you can use any material as long as you don't have big rubble or 2 inch or bigger kind of boulders, rubble in it. Now the benefit of this to the contractors, land developers, and the city is, as an example, we've got looked at scenarios here for a 100-meter run of pipe of various sizes, and assuming a 10 cubic meter dump truck, for a 750 millimeter pipe, when you're digging out this entire area and disposing of that, you'd have 14 truckloads you need to dispose of for every 100 meters of pipe. Versus this Class B bedding, you'd only have 6 truckloads to take away. And you may also even be, because you're only really disposing of this, you may be able to use this on site. And that Class C bedding we showed earlier would be even better. You'd only have 4 truckloads to take away. It might cost you a higher class of pipe, so it'd be a price expense there, but you'd save on disposal fees, fuel, wear and tear on the trucks. with the some do's and don'ts here of the pipe installation, just to wrap up. Our pipe 750 millimeter and down has this flared out bell on it. So we ask that, and we've heard from previous groups, most contractors are putting a little groove in the bedding there for that bell to rest in. We want you to support the whole length of the pipe, the barrel, and have a little divot for the bells to stick into. What happens if the scenarios that you run into when you don't do that is all the weight is supported on the bells and you've got a gap underneath the pipe. When you put all that weight of your fill on there, it's just going to snap underneath. Like there's nothing to support the pipe underneath. You put all this heavy load of backfill on top, it's going to crack underneath, like we show here. Similarly, if you don't have a uniform support and you've got rubble and rocks in there, you can create a point load. So you've got a rock underneath there, you put your flat pipe on top, and then all the weight of the fill on top of it is just going to snap on that one point load. So you're going to end up with a circumferential crack. And then the humorous example we always show here is we don't like to see a giant excavator being used to push the pipe down onto grade. You're just basically doing the same kind of thing here. You're putting a point load right on one spot of the pipe. I know they need to use these machines to lift the pipe into the ground, but even if they rotate their bucket and use the flat backside to push down over a larger area, it's better than point loading it. So that's it for bedding, pipe installation. You guys have any questions? Or?